Well, students, we know aldehydes are more reactive compared to ketones. It is due to the two bulky group attached to the carbonyl group or C double bond O group in ketones. But in case of aldehyde, we have one nitrogen attached to C double bond O. Group is small, so reactivity is greater compared to that of the ketones. Well, in oxidation, aldehydes easily undergo oxidation even with mild oxidizing agent, and this reaction is used as a test to distinguish between aldehydes and ketones. A simple tolerance reagent and one more, it's a pairing solution is used to distinguish between aldehydes and ketones, because with the tolerance reagent and with pairing solution, only aldehyde undergoes oxidation to give the carboxylic acid, and you are observing colored PPT for aldehyde with tolerance reagent, black PPT you are getting, and with pairing solution you are getting the red precipitate. So let us discuss on that. Well, aldehydes undergoes oxidation with mild oxidizing agent like tolerance reagent. It is called ammonical silver nitrate. Ammonical silver nitrate. To give black PPT of silver, and with pairing solution gives red PPT of cuprous oxide. But ketones do not gives PPT with tolerance reagent and pairing solution. So we say test to distinguish between aldehydes and ketones. Therefore, this reaction is used. As a test to distinguish between this reaction, not one, both reaction, used as a test to distinguish between aldehydes and ketones. So tolerance reagent, ammonical silver nitrate. Now I am writing A with the tolerance reagent. Well, tolerance reagent is nothing but the reagent obtained by adding 1 to 2 drops of NaOH solution into 1 ml of silver nitrate solution. You are getting the brown color PPT. That brown color PPT slowly dissolved by adding ammonia solution, that is dilute ammonium nitroxide. Dropwise it is added till it dissolves. That solution is called tolerance reagent. So I am writing the equation here. RCHO, we know this is aldehyde. Tolerance reagent is nothing but it's a complex of silver AgNH3 twice, then plus. This is tolerance reagent. Question comes, write the formula of tolerance reagent, then you have to write this one. It is AgNH3 twice. So we are adding NaOH, that means we have OH minus. Now RCHO, we know aldehyde undergo oxidation. It gives RCOO minus. Or you may write RCO, Na when we have NaOH, but OH minus is written, so it is RCOO minus. And you are getting the silver as a PPT. It's in the form of a black color. So black PPT of silver. Now we have one more NH3. NH3. We have OH and one more hydrogen. Here there is no hydrogen. That means that we write H2O. What is the equation? It's 2. Here it is 2. The number of the nitrogen or NH3 become 4, so it's a 4 NH3, and in order to balance the oxygen you have to write 3 times here, so it must be 2H2. This is a gas. So usually you are heating this one, heating this mixture to get the black silver mirror or it's a black color PPT. Examples, we can write Aldehydes, CH3CH. We can write benzaldehyde. Usual reaction, it's a plus. I am writing for this one. It's a 2Ag NH3 twice. It's a complex form of the silver. We have a charge on this, the positive charge, plus 3OH minus Aqueous. So this on heating, you are getting RCOO minus, means R is here, CH3, then 2Ag, it's a black color PPT, then ammonia gas and H2. So you can write equation for benzaldehyde also. The product is this benzoate ion C6H5 CO minus, remaining to the same. So you have to complete this one at home with pairing solution. With pairing solution, you are getting red color PPT of cuprous oxide. So pairing solution is nothing but it's a mixture of copper sulfate, sodium tartarate with NaOH. So you have two, pairing solution A and pairing solution B. It's a copper sulfate and sodium tartarate with NaOH. They are mixed in equal proportion, then treated with the aldehyde just on warming, even sometimes on shaking also. You are getting the red color PPT of cuprous oxide. So equation is aldehyde RCHO. Then cupric salt Cu2 plus it is OH minus gives RCOO minus, then you are getting cuprous salt, red color PPT. Here we have black, here we have red color PPT, and then H2O. In order to balance this one, here you have to write 5 times, this must be 2 times, See the charge, it's a 4 minus 1. On this side also minus 1. Charge is balanced. Number of copper is also balanced. Oxygen is here we have 5 and 1 6. That means we have to write 3H2O. Number of hydrogen are 6. Equation is balanced. So remember, this is tolerance reagent. This one is pairing solution. Pairing solution. Which color PPT you are getting? Red color PPT. What's that red color? Cuprous oxide, Cu2O. What's a black color or a silver mirror? It is nothing but silver. That means plus 2 is reduced to plus 1. Oxidation state of copper is plus 1. Here plus 1, moon is 0. It is a molecule. This one is ion. Plus 1 become 0. Well, tolerance reagent get reduced to silver. Pairing solution Cu2 plus get reduced to Cu plus, that is cuprous oxide. What about this aldehyde undergo oxidation? Aldehyde of oxidation use carboxylic acid or carboxylate ion. Here also carboxylate ion you are getting. Well, in this case, benzaldehyde do not react with pairing solution or do not use the red precipitate. Benzaldehyde do not use red precipitate the pairing solution because we know pairing solution is alkaline in nature, and in alkaline solution benzaldehyde undergo Keniger reaction. Well, I am writing example here. Example CH3CHO acetaldehyde plus Cu2 plus 5OH minus. All these are aqueous solutions. Aqueous, yields aqueous solution. So, product is CH3 COO minus aqueous plus Cu2O, it's a red color PPT, plus 3H2O. Well, benzaldehyde do not use red precipitate with the pairing solution. Why it is so? Because it undergo Keniger reaction as the pairing solution is alkaline in nature. Well, I am writing that one because you may not be remembering these words. So, I am writing here benzaldehyde do not use red PPT. Benzaldehyde do not use red PPT with pairing solution. Because it undergo Keniger reaction. Keniger's reaction as pairing solution is alkaline in nature. Alkaline in nature. Pairing solution is alkaline in nature. So, with the pairing solution, so oxidation of aldehydes and ketones. Ketones do not undergo oxidation with the mild oxidizing agent. However, with the strong oxidizing agent like KMnO4, it is oxidized to carboxylic acid containing less number of the carbon atoms. Well, after this, oxidation now. Methyl ketone, next property, oxidation of methyl ketone. That means it may be aldehyde also. We know ketone is C double bond O, methyl is CH3, and one more may be hydrogen or some other group like hydrocarbon group, oxidation of methyl ketone. So I am writing that one as CH3 C double bond O. This group is called methyl ketone, and one more may be R. So R may be H or R may be hydrocarbon. This R may be, it may be hydrogen or hydrocarbon group. Hydrocarbon group. Hydrogen or hydrocarbon group. Well, so methyl ketones undergoes oxidation with the sodium hypohalite. So remember the formula for sodium hypohalite. It is NaOH, and that sodium hypohalite is obtained by mixing sodium hydroxide with the halogens like chlorine, bromine or iodine. If it is chlorine, you are getting sodium hypochlorite, bromine, sodium hypobromite, and suppose if it is iodine, sodium hypoiodite. Well, so aldehydes and ketones, having CH3 group attached to CO group undergoes oxidation with sodium hypohalite, to give sodium salt of carboxylic acid, sodium salt of carboxylic acid, and halo form. So formation of halo form is one of the important product takes place when the aldehydes or ketones or even alcohol which is attached, that is COH, that means OH group attached to the carbon adjacent to CH3 or CH3CHOH group undergo this reaction. For example, ethanol CH3CH2OH. This also answers the iodoform test or haloform test. Then CH3 CHOH CH3. This also answers the iodoform test because this one undergo oxidation to give the C double bond O. So we have methyl ketone. This one undergo oxidation to give the CH3 C double bond OH. So we have methyl ketone. That means the methyl group attached to carbon containing OH group. Followed, methyl group attached to carbon containing OH group undergo oxidation to give the methyl ketone, and that gives the halo form. Well, example, I will give one more example. CH3, then it is a CHOH, CH2CH3. This will undergo haloform reaction or not? Yes, because we have CHOH attached to CH3. Suppose if it is like this CH2CH3, no. Why? Because the CH3 group is not there, it is attached to CHOH. So this one do not undergo halochrome reaction. halochrome reaction ಆಗಬೇಕಾದ್ರೆ CH3 ಗೆ CO ಕೂಡಿರಬೇಕು. CH3 CO ಗೆ ಕೂಡಿರಬೇಕು. ಇಲ್ಲ ಅಂದರೆ CH3 CHOH ಕೂಡಿರಬೇಕು. ಈಗ ನೋಡ್ರಿ CH3 CHOH ಕೂಡು, CH3 CH2OH ಈ ಕಾರ್ಬನ್ ಕೂಡುಂಟು OH. ಬೈ ಚಾನ್ಸ್ ಈ ಟೈಪ್ ಇದ್ರೆ ಆಗುತ್ತಾ? No. Why? Because CH3 is not attached to CHOH. It is attached to the CH2. ಹಂಗಾಗಬಾರ್ದು, ಅವಾಗಲ್ಲ. ಇದು ಕಾಮನ್, ಮಿಥೈಲ್ ಕೀಟೋನ್ ಕಾಮನ್, ಅಥವಾ ಹೊರತಾಗಿ ಆಲ್ಕೋಹಾಲ್ಸ್ ಕೂಡ ಕೊಡುತ್ತೆ. ಸೊ ರಿಮೆಂಬರ್ ದಿಸ್ ಪಾಯಿಂಟ್ ಆಲ್ಸೋ. ಓಕೆ, to give sodium salt of carboxylic acid and halochrome. So NaOH, sodium hydroxide plus X2. You are getting NaOX, sodium hypohalide and H2O, then it's a NaX. That means you have to write 2 times NaOH. This is sodium hypohalide. Sodium hypohalide. Said maybe in this form or this mixture that can also be used. So it is CH3 C double bond O R. That R may be H or hydrocarbon group. Hydrocarbon group. Plus it is NaOH. So you are getting it is R C double bond O CX3. This is important. H is replaced by X plus 3 NaX plus 3 CX3. 3 hydrogens here, so 3 NaOH. Okay, afterwards R C double bond O CH3 plus NaOH. The product formed is R C double bond O OH. I mean ONA plus CH3. This is called halochrome. This is called halochrome. Remember this one. This equation is important. This reaction is also important. Even previous one also important. So it's a test for methyl ketone. This reaction is used as a test for methyl ketone. All methyl ketone answer this reaction. And one more point is that suppose the R contains unsaturated group, there is a carbon-carbon double bond in the R. For example, we have CH2, CH double bond, CH2. Then the double bond is not affected by the sodium hypohalide. This point is also important from the point of competitive examination. Which one? The double bond is not affected by sodium hypohalide. Suppose if you are using strong oxidizing agent, then double bond breaks and you are getting the ketones or sometimes aldehyde. Depends on to double bond present on which type of carbon. You may get the ketones or aldehydes if it's a strong oxidizing agent. So this is not that much strong. So here the double bond is not affected by the sodium hypohalide. So example CH3 C double bond O CH3. We know this is called acetone or propanol. Acetone or propanol plus NaOR, sodium hypoiodide. Sodium hypoiodide. Sodium iodide. So the product is CH3 C double bond O Cr3 plus 3NaOH. One of the CH3 group changes to Cr3. Next is R, iodine. Well, afterwards this one undergo hydrolysis. Which one? This one undergo hydrolysis. CH3 C double bond O Cr3 plus NaOH. The product is sodium salt or carboxylic acid. CH3 C double bond O ONA, or sometimes you can write CH3 C double bond O minus also you can write, because sometimes it's in the paper, instead of giving the sodium salt, the formula may be given like CH3 C double bond O minus. So don't get confused there. It's nothing but a salt. The salt do not exist as a CH3 C double bond ONA. In solution it exists as CH3COO minus and Na plus, because it's ionic, as we know this one, plus CHI. So yellow color PPT, yellow PPT. So iodoform, CHI is so yellow color PPT, iodoform, iodoform. If it is chlorine, then chloroform. Bromine, bromoform. So you have to complete from equation. The equation is, complete this one. So over A, it is C6H5 C double bond O CH3 plus NaOC. We have two reactions, complete this one, and then second equation. Two equations we have. To complete the first equation, then complete the second equation. The second equation plus NaOH. So I have to write this one, X. Here we have X. Plus something we are writing. B. It's CH3 C double bond OH. We know this is called as aldehyde, plus NaOBr. Complete the equation. We have two equations again. One is the formation of I3 or X3, then double bond OH or whatever it may be. Second one, that product interact with the NaOH to do the halo form. So all these reactions are important from the point of board exam and also from the point of competitive examination. So to be perfect in all this. Well, after this reaction, we have a reaction which is related to the hydrogen atom with respect to carbonyl group. So hydrogen atom with respect to carbonyl means adjacent carbon hydrogen. We know that is called alpha carbon. So reaction due to alpha hydrogen. Let us discuss on that. Okay. So reactions of aldehydes and ketones due to alpha hydrogen. Reaction due to alpha hydrogen. Reactions due to alpha hydrogen. So first you should recognize which is alpha hydrogen. Then we can write equation. It is not difficult. So this is alpha hydrogen, CH3. Then C double bond OH. So this one is alpha adjacent to the functional group CHO. This is alpha. How many alpha hydrogen we have totally? 3 alpha hydrogen. These are the 3 alpha hydrogen. So totally we have 3